This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is August 2026. And what a month. It seems like every month is a neat month, and August is no exception. Do you realize that we have two eclipses happening? We have a solar eclipse happening. We have a lunar eclipse happening. Every summer we have the Perseid meteor shower, definitely, arguably, one of the best meteor showers in the course of a year. That's coming up. We have the launch of a brand new satellite going up the end of August. It's just amazing the things that are happening in the month of August. And we have a lot to tell you about. And so stay tuned. And then towards the end of the show, we'll talk to you about some of the great things that you can see in the night sky. One of them is the summer triangle, easy enough for you to find. Well, we're going to get started, and I have, once again, a special guest joining me, Seth Roop. Welcome again, Seth.
Thank you for having me. It's a pleasure.
Yeah, I hope it's nice to be had.
It is.
So to speak.
Truly.
Yes. So we're going to get started with the Perseid meteor shower. And so have a look, and you can see what an image of the meteor shower could look like. This is obviously time-lapse with a variety of meteors, but one thing you might notice is they all seem to be coming from the same place, and that would be in the constellation of all places, Perseus. So Seth, tell us a little more about the Perseid meteor shower.
Yeah, so the Perseid meteor shower is it's one of the best ones of the year. It's a really exciting meteor shower. And you can expect the peak on the night of August 12th into the morning of August 13th. And you can see the meteors anywhere in the sky. But they'll all be, as Dave said, they'll all be coming from the same place, which is near the constellation Perseus, which is where it gets its name. If you're watching for a couple hours, the point of origin, it will move. As you know, as the sky rotates, as the Earth spins, the point of origin will move. So if you're out there for a few hours, you're going to want to keep track, or just follow the direction the meteors are coming from. It's obviously best to see these meteors after dark, through the night, probably after 11 p.m. or so is probably when you'll start to see peak conditions. And during that peak, you can expect to see up to 60 meters an hour possibly, or some years even more, dependent. But for the best results of viewing, it's good to stay out there for a few minutes, if you go out.
Dare I say, if I could interrupt
Please.
you there for a moment, how about a few hours? As noted on the slide, they get out your lawn chairs, which you should still have out in August. Get your lawn chairs out, call your neighbors, tell them to turn their lights out, right? At least their porch lights, their driveway lights out. And, get some donuts, get a sleeping bag, blanket, be warm, and enjoy yourself, because it definitely is worth a couple hours of your investing. And as Seth said, after 11, after midnight, when Earth is actually facing the direction that the meteors are coming from, excuse me, is going to be the best. So, and then, recline and enjoy, do it with friends, families, have a media party over your house is really great. And a bonus that we have is there's no moon. I mean, the moon is obviously up there, but we just passed the phase new moon, so there's no moon in the night sky. And so we have the advantage of having a really dark sky to be able to see the maximum number of meteors. And as Seth said, we're 60 plus an hour. That's like a meteor a minute on average. And this is unique because it's been a lot of years since we've had a really dark sky. And of course, no clouds.
Of course.
What else, Seth?
Well, so I think it's definitely interesting to learn a little bit about what you're looking at and why it's there. Why are there meteors coming down from the sky, from the spot in the sky? So as you may or may not know, most meteor showers originate from debris trails, specifically of comets, and the Perseids are no different. The meteors that are entering the atmosphere are coming from the debris trail left by comet Swift-Tuttle. And this comet has an orbit of 133 years, which isn't actually too long by comet standards. And so as the comet orbits around the sun and it gets closer to Earth and closer to the sun, the heat of the sun evaporates the comet. That's what gives it its tail, and it leaves debris in its wake, and the orbit of the Earth will eventually intersect with that debris trail, and those tiny little pieces of debris, which are about the size of a grain of sand, enter the atmosphere, burn up in the atmosphere, and that is what you see as shooting stars, as they're known.
So, yeah, and some people refer to them, obviously, as you just said, as shooting stars. But one thing I like to remind people of is stars don't shoot. They explode. It's much more dramatic when a star dies. So as Seth said, these shooting stars that you see are just about the size of a grain of sand. And the reason that they glow so brightly is they're going really fast, anywhere from 25,000 to 160,000 miles an hour, and they impact the atmosphere, which creates what we call ram pressure, which causes it to heat up and glow really bright, even though it's relatively small. And if you had something the size of a pea, it would produce what you might refer to as a fireball. So, yeah, you don't want to miss the Perseid meteor shower because it's, the Geminids, there's a Geminid meteor shower that I usually mention in our January show, which is also a really good shower. But the Perseids just seem to be more popular because it's warm in August and more people don't mind going out and, spending some hours out looking up at the sky in the winter. It's cold. But an advantage, just looking ahead to January in the Geminids, there's no bugs. So you have that as an advantage. Anything else, Seth, comes to your mind about the Perseids you'd like to mention?
Well, I think as you may have already mentioned, they're the same time every year, roughly, so you'll know when to expect them. And that's true of all our meteor showers. We're intersecting those debris trails on our orbit at the same time each year. So it's one of those astronomical events where, aside from cloud cover, there's not a lot of guessing involved. And meteor showers are always, even the slower meteor showers, really a treat. So highly recommend. Go out, spend some time outside, and see the Perseids.
And though the date, as Seth mentioned, we're talking about late night, August 12th, early morning, the wee hours of August 13th. But really, a day or two before those dates, a day or two after those dates, we're still in the season of the Perseids, which actually, the season of the Perseids begins at the end of July, so we're already in the season of the Perseids. But get out and enjoy them, and obviously, particularly if it happens to be, or looks like it's going to be cloudy on those nights, then you want to get out, a day or two before or a day or two after is perfectly fine. So, next coming up, as I mentioned at the top of the show, we have 2 eclipses happening. We have a lunar eclipse coming up, which we're going to explain in detail, and we have a solar eclipse coming up. And you may have heard us say when we had the big eclipse in April 2024 that the next total eclipse in New Hampshire was going to be in May of 2079. And that's true. But this eclipse that we're going to be talking about that you can see in New Hampshire and other parts around the country and such is really neat, because regardless of whether it's total or not, it's a lot of fun to be able to watch a solar eclipse. So Seth, this one is going to be a partial solar eclipse.
Yes. So a partial solar eclipse, it's a little less spectacular than what you might think of when you think of a total solar eclipse, but nonetheless, really very interesting, very beautiful, and totally worth taking the time to observe. Disclaimer, you absolutely need to use protection for your eyes when you're doing a solar eclipse, but we'll get to that. So as Dave said, August 12th is going to be the date. And what you would see we have an image of sort of what you would see if you used eclipse glasses or a solar filter to view the sun. You would see what is actually the moon beginning to cover a portion of the sun. Kind of looks like a bite is being taken out of the sun. You can expect a coverage of between roughly 16 and 20%, depending on your location. Further north in the state, you'll tend to see a higher coverage, as well as further east, because the totality of the eclipse is I believe, over Greenland. It's towards the east.
And Iceland.
And Iceland, yes.
We got a short little video clip here. Time and Date is a great website to go to for all kinds of information related to the sun and the moon. But we got this little video clip from Time and Date that's just going to give you an idea of what you can expect to see from New England, basically. But obviously we're centered in Concord, where we record our show, but we realize people watch the show all over the country, and hope that you enjoy this little video clip now. So you can see that's the most bite we're going to get out of it in Concord, and then over time it phases away.
And one thing I think it's important to remember about these eclipses is that you could go probably without even realizing that it's happening.
Right.
If you did not have the proper viewing equipment. It's not a partial solar eclipse like this. It's not going to dim it's not going to make it like nighttime out. You actually might not even notice a difference in the brightness outside. So that's why you really need to use different equipment like solar glasses or a solar filter on your telescope to properly view the eclipse.
Check out some of these times here that may be a help, particularly for people in the Concord area, but it's similar if you're in the greater Concord area, and you can check out the area online for your own location. So the partial eclipse, when you're just going to start to see the dent or the bite taken out of the sun, is going to be just a little bit before 1 o'clock, and this is Eastern Daylight Time, so 12:58 and 44 seconds if you're really interested. And it tells you the direction, so basically you're going to be facing south. 180 degrees is facing south, and then the altitude, 61, we'll call it 62 degrees above the horizon. And then the biggest bite that is going to be taken out is at what we call maximum eclipse, which for this one is going to be at 1:52, so about 8 minutes or so before 2 o'clock in the afternoon. And you can see the direction now is moving a little more towards the west at 209 degrees. Altitude very slightly coming down to about 59 degrees. And then the whole thing is going to be over basically at 2:45 in the afternoon. It's going to be finished. But as Seth pointed out, important, you have to be paying attention, because even if the eclipse was like 80% coverage, if you're not aware, you're probably not going to notice, because it happens so gradually that you're not going to notice what's going on. And obviously, very dramatic is the total solar eclipse, which again, for this one, you need to be over in eastern Greenland, Iceland, and then the path goes down. You can look it up online to see the exact path, because who knows, maybe you want to buy a plane ticket and get there. I do have some friends that are eclipse chasers that are going to be looking for how it happens. So Seth, tell us, how does a partial eclipse happen?
Yeah, of course. So all solar eclipses sort of happen in the same way, and that is when the moon crosses between Earth and the sun, and it blocks out some of the light of the sun. Imagine it's actually not too dissimilar from if you were on the beach and a cloud went in front of the sun, and it casts a shadow over you. In a solar eclipse, the moon is doing the same thing. It is passing in front of the sun, and it's casting a shadow on the Earth. And if you are within that shadow, you will witness either a partial or a total solar eclipse. The way to know which one you would see depends on which part of the shadow you are in. There are two parts of the shadow called the umbra and the penumbra. The umbra is the darker, more centered part of the shadow you see here. That's where you would see totality. The penumbra is the more diffused, lighter shadow, and anywhere in there is where you would see a partial eclipse. And the further away you are from sort of the center, so to speak, the less totality or the less coverage you would see, and the closer you are to the center, the more coverage you would see.
Right. And as already pointed out, you need the eye protection. You need to use the eclipse glasses if you have those. Or Seth discovered this really kind of cool trick for viewing.
So this is actually a trick I learned in college from an astronomy professor. A colander is probably the best suited device.
I just had spaghetti last night, and we used one.
So you know you're ready. You could also, in lieu of a colander, you could use a piece of paper with holes poked in it, or something akin to that. What's important is that there's just these very small, tiny holes for light to pass through. And when you do that during a total eclipse, what you will see, as shown in this image here, is the shadows cast by the light passing through the pinholes of the colander will actually reflect the coverage of the sun. So you see these light crescents. That's the sun that's uncovered, and the dark part is what is being covered by the moon. So it's a really safe and easy way to view the eclipse that almost anyone can do, and you're not going to hurt your eyes.
And that's an important thing, not to hurt your eyes. And it's kind of neat to see so many little eclipses happening on whatever you're projecting on, a piece of paper or whatever. And then, as mentioned, we have a lunar eclipse coming up. And the nice thing about the lunar eclipse we have coming up is it's a whole lot more coverage. We mentioned that the solar eclipse coming up is going to be 16 to 20% coverage, depending on where you are. But this lunar eclipse, we're looking for 94+% of the moon being covered. So you can see the times there, 9:23 Eastern time, and then it's going to be over at 3 a.m. Eastern time. But the important thing that you're going to need to know is that it starts when the moon is like just rising in the east. So you need a good eastern view, and you don't need to call anybody to say, well, where do I look for the moon? I mean, you need to be able to find the moon. And you'd be surprised the number of times that perhaps somebody calls, like the Krista McAuliffe Discovery Center, the planetarium. Well, where do I look for the moon? I mean, it's the moon. You go find the moon. But just to give you an idea, again, on this night, late night the 27th, it's going to be over in the east when it's going to start to happen over there. And Seth, what makes a lunar eclipse different from a solar eclipse?
Yeah, well, so actually the process by which they happen is actually very, very similar. It's still involving the same three bodies, right? The sun, the earth, and the moon. But in this case, as opposed to the moon coming between the sun and the earth, we have the earth coming between the sun and the moon. And the earth is acting as the shade that casts the shadow. And you can see it has the penumbra and umbra, just like a solar eclipse, a dark part of the shadow and a light part of the shadow. And those are cast over the moon. And from Earth, we see that as our eclipse, which is usually a red color that comes over the moon. And you don't need eye protection to view. It's totally safe to just go out and look up at the moon and see the lovely colors, and definitely don't want to miss it. It's a very cool thing to see.
And the thing is that is also really pretty nice is that you're going to get to see the whole moon, and it's going to be just about all covered. And I would have your camera ready, your phone ready to take some images, because it takes a little while because Earth is rotating, the moon is in motion, and the moon actually moves slowly from west to east against the background of the stars. Now we have another little animation to show you, and this shows you where the moon is in terms of the constellations, and the moon is going to be in the constellation starting out here in Aquarius. You see that reddish glow that you should be able to see, and then there's just a tiny little fingernail of lit moon that is not going to get covered.
And as cool as it is to say there's a total lunar eclipse, I think sometimes the partial eclipses, especially when you have this high level of coverage, a partial eclipse can be even cooler, because what you get to see the really cool deep red of the eclipse, but what you also get to see is the contrast between the regular moon, if you will, and its regular color, and the portion of the moon that is shaded by the eclipse.
Yeah, very, very cool. Now, one thing that we also mentioned at the top of the show is there's a new space telescope going up, and this is the Nancy Grace Roman Space Telescope, and it's going to provide a new view of the universe. And we want to let you know that if you are able to get to Concord, New Hampshire, the state capital, and get yourself to the McAuliffe Shepard Discovery Center on August 30th, which is the date of the launch. The launch is going to be, at the moment, scheduled for 7:20 in the morning, but the rest of the day, the Discovery Center opens at 10:30, closes at 4 p.m., and throughout the day there are going to be various activities and exhibits related to this very, very special telescope. So Seth, tell us what some details might be about the Nancy Grace Roman Space Telescope.
Yeah, absolutely. So it's going to be launching in about a month, I think 31 days from our recording this, I believe. And it's going to be launching in Florida from the Kennedy Space Center. And I believe it'll be launching on a SpaceX rocket. And it'll be orbiting, I think it's something like 1.5 million kilometers from Earth at a Lagrangian point between Earth and the Sun. But it's going to be up there with some very special and interesting instruments that are going to be really able to do some cool things. The mirror that it's equipped with, which you can see in the image here, and there's actually a person sort of to give you some scale. It's nearly 8 feet wide. It's 7.9 feet, 2.4 meters in diameter, which is equivalent to the Hubble Space Telescope. And one of the two main instruments that it is equipped with is the Wide Field Instrument, or WFI, which is a camera that is pretty much equal in capability in terms of resolution to the Hubble Space Telescope, but it will have a much larger field of view. So if you imagine the Hubble Space Telescope was able to visualize a narrow slice like this, imagine a slice 100 times wider, and so that will substantially increase the range and the amount of objects and images that can be captured by the telescope.
And they're predicting that they're going to be able to see around a bit over its lifetime of operation, billions of galaxies, and imaging them and figuring things out, because obviously one of the big questions in our universe is, how does everything work? And it seems like every time we go to answer one question, we get 2 or 3 more questions.
Yeah.
How is that happening?
Yeah.
And one of the neat things too that this telescope will also start to give us some more input to is the ideas of dark energy and dark matter, which remain mysteries to this moment in time, for sure. Well, Seth, thanks so much for being on the show.
Absolutely. It was my
with
pleasure.
us today, and all the information that we were able to share together. It was really awesome. August is a great month. And so we're going to take a look at a portion of the sky that and a few constellations that you can just go out and enjoy in your backyard. Well, I hope you enjoyed that time with Seth. And Seth was a former student of mine at Belmont High School astronomy class, astronomy club. And he's heading off to Ohio working on his master's degree in music, clarinet in particular. And so it's always great to have Seth back on the show. Now what I want to show you is what's called the summer triangle, and it's pretty much overhead. So I don't think you're going to miss finding these stars out in your backyard. So the constellations I decided to start with. The bright star you're going to be able to see near an overhead position. The brightest one is called Vega, and it is in Lyra, the harp. Then Deneb means tail, and Deneb is either the top of the Northern Cross or the tail of the swan. And then we have a star called Altair, which is in Aquila or Achaea, the eagle. So this is just the art representation of what the constellations are, and then to just limit it to using the lines, perhaps you can see a little bit. From Vega, you have this quadrilateral, and maybe you can picture some strings going here. And just so you know, right between the bottom 2 stars is what's called the Ring Nebula, and that's just an awesome sight. So if you have an opportunity to look through a telescope, perhaps the first Friday night of any month at the McCall Shepherd Discovery Center, like August 7th, if it's clear, ask some of the astronomers with their telescopes from the New Hampshire Astronomical Society to show you the Ring Nebula right here. Then Deneb, as I mentioned, is at the top of the Northern Cross, and I think you can see the cross right there. But we add a couple stars, one on either side, and voila, we now have a swan. And the easy way to find Altair is that it has a star on either side of it that is pretty easy to find. So those 3 stars make up what we call the summer triangle. Now, I missed putting the 3rd line here. So we have Deneb, the top of the Northern Cross. We have Vega, the brightest star in an overhead position. And then finishing this last line that I just neglected to do down to Altair. And you see that is the summer triangle. And in the summertime, if I'm hungry, I like to call it the summer pizza slice. So 3 constellations, 3 stars, easy to find in the night sky. So I hope that you enjoy that. And don't forget about the eclipses that we have. And then be on the lookout for the Nancy Grace Roman Space Telescope launch, which is going to be on August 30th, 7:20 in the morning. Check it out on TV or watch the reruns on the news. But get yourself, if you can, to the McCall Shepherd Discovery Center in Concord, New Hampshire. And all day from 10:30 to 4, there'll be special activities and exhibits related to this great space telescope that is going up. And Nancy Grace Roman was also one of the pioneers of the Hubble Space Telescope. And it's going to be giving us a new view on the universe. So don't miss that. Visit the McCall Shepherd Discovery Center on August 30th. So that's our show. I hope you enjoyed it. Hope you learned some great things. And don't forget to keep looking up.